Beneath the surface of our oceans lies a world we were never meant to see. A realm where light dies completely. Where the rules of life, as we know them, stop applying. Where evolution has taken forms so strange, so alien, so deeply unsettling that scientists who study them still cannot fully explain what they are looking at. We have sent rovers to Mars. We have mapped distant galaxies millions of light years away. We have charted mountain ranges on the surface of the moon with extraordinary precision. And yet the deep sea, the largest living space on our own planet, we have explored less than 5% of it. Let that sit for a moment. More than 80% of our own ocean remains completely unknown to us. And what little we have seen has already shattered nearly everything we thought we understood about where life can exist and what form it can take. This is not a story about fish. This is a story about what happens when you go deep enough. Because the deeper you go, the stranger it gets. And the stranger it gets, the more it starts to feel like something that should not exist at all. At the surface, the ocean makes sense. Sunlight penetrates the water. Plankton blooms. Fish feed on plankton. Larger animals feed on fish. Entire food chains stretch from coral reefs to whales, all of it powered by the same energy source that powers almost every living system on land. It is familiar. It is logical. It follows rules we understand. But drop below 200 meters and everything begins to change. The light starts to fade. Slowly at first, then faster than you would expect. By the time you reach the edge of what scientists call the Twilight Zone, a vast belt of ocean stretching from 200 meters down to a full kilometer below the surface, the sun's rays have become too weak to fuel photosynthesis. The plankton forests disappear. The green energy that powers surface life simply does not reach here. What replaces it is something almost poetic in how bleak it is. Scientists call it marine snow. Tiny fragments of dead plankton. Waste particles. The physical remains of animals that died above and are now slowly sinking downward through the water column. To us, looking at it through a submersible window, it looks insignificant. Barely visible. Almost nothing. To the creatures living here, it is everything. It is the only food that exists. And where there is food, however scarce, life finds a way. But the life that has found a way down here does not look like anything you would recognize. Many animals of the Twilight Zone are transparent. Their bodies have become glass. The glass squid drifts through the water with organs barely visible, a ghost against the fading blue. The glass octopus is almost entirely invisible, its eyes the only solid feature in an otherwise see-through body. Why so many species independently evolved transparency in this zone is still not fully understood. It may be camouflage, a way to vanish in the last traces of filtered light. Or it may be something stranger. A way to conserve energy in a world where producing even a single pigment costs more calories than the animal can afford to spend. Others have made the opposite choice entirely. Instead of becoming invisible, they have learned to make light. In the deepening gloom, some creatures generate their own glow through a chemical reaction called bioluminescence. Flashing dots. Glowing patterns. Entire bodies flickering like living lanterns in absolute darkness. To us, seeing footage of it for the first time, it looks beautiful. Otherworldly. Almost magical. But down here, light is not decorative. Light is survival. Some creatures use it to lure prey directly into their mouths. Some use it to find a mate in the vast, dark, featureless water column. And some, remarkably, use it to disappear. This trick is called counterlumination. From below, a predator searching for food can detect a dark silhouette moving against the faint shimmer of light filtering down from above. It is a silhouette that gives away your position and your size. To counter this, animals like the firefly squid cover their undersides with light-producing organs called photophores. They adjust the brightness of these organs in real time to precisely match the glow coming from the surface above them. The result is that their outline disappears entirely. They are hiding by making light. Using light to become invisible. In a world defined entirely by who can be seen and who cannot, this is one of the most sophisticated survival strategies ever evolved by any animal anywhere on Earth. And then there are the games that get stranger still. The bloody bellycomb jelly shines deep red in the darkness. But down here, red wavelengths of light never penetrate. Which means to every predator in the Twilight Zone, a red object appears completely black. Invisible. The jelly exploits this perfectly. Inside its stomach, bioluminescent prey sits concealed, its glow hidden from any predator that might otherwise detect it through the jelly's body. It is a living black box. Using physics itself as camouflage. Each night, as darkness falls on the surface above, something extraordinary happens across this entire zone. Billions of creatures begin to rise. Lanternfish. Squid. Jellies. An entire army of deep-sea animals ascending toward the surface in coordinated darkness, feeding on plankton under cover of night before sinking back into the gloom at dawn. This vast daily movement is called the Deal vertical migration. It is the largest synchronized animal migration on Earth. Greater in sheer numbers than every land herd, every bird flock, and every insect swarm combined. And yet despite its scale, this event remained completely hidden from human knowledge until World War II. Naval sonar operators began detecting what appeared to be a false seabed. A dense layer that rose every single night and sank back down every morning. For a period, no one understood what they were seeing. It looked like the ocean floor was moving. It was not the ocean floor. It was life. Billions of animals moving as one, invisible to the surface world, following a rhythm older than our species by hundreds of millions of years. Past 1 kilometer, the last traces of sunlight disappear completely. We have entered the midnight zone. A realm stretching from 1 kilometer all the way down to 4 kilometers below the surface. Here, there is no dawn. There is no dusk. There is no cycle of light and dark. There is only permanent, total, absolute night. Temperatures hover just above freezing. Pressure is hundreds of times greater than what we experience at the surface. To a human body, even with a pressurized suit, this environment would be lethal within seconds. And yet, this is where evolution becomes most creative. The dragonfish is one of the most remarkable examples. Unlike almost every other creature in the deep, it can produce red bioluminescence. And because red light does not penetrate to these depths, most animals here have no visual system capable of detecting it. To them, the dragonfish's searchlight is completely invisible. It can illuminate prey, scan its environment, hunt actively through the darkness, and not a single predator or prey animal around it can see the light it is using to do so. It has invented a private wavelength. A color visible only to itself. Other predators here are cloaked in something that should not be physically possible. Some deep-sea fish are coated in ultra-black skin, so extraordinarily efficient at absorbing light that it reflects less than 0.5% of anything that touches it. When researchers shine a direct spotlight from a submersible onto these animals, they almost vanish. The light hits their surface and simply does not come back. It is as close to true invisibility as anything in biology has ever achieved. And then there are the anglerfish. Perhaps the strangest hunters in the entire ocean. The female dangles a luminous lure directly in front of her open mouth. Small animals drawn toward the only light source visible in the total darkness swim directly toward it. They do not survive the encounter. But the anglerfish's greatest mystery is not how it hunts. It is how it reproduces. Male anglerfish are born tiny. Weak. Physically helpless. They have one biological purpose. Find a female. In the vast, dark, featureless midnight zone, this is nearly impossible. The ocean at this depth is enormous. Encounters between individuals of the same species are extraordinarily rare. When a male finally locates a female, he latches onto her body with specialized jaws. And then something happens that has no parallel in any other vertebrate on Earth. His body begins to fuse with hers. His organs dissolve. His eyes disappear. His internal systems shut down one by one until he is nothing more than a reproductive attachment permanently embedded in her tissue, supplied nutrients directly from her bloodstream. He does not hunt. He does not move. He does not think. He simply exists as a biological function, attached permanently to the animal that has absorbed him. It is one of the most extreme reproductive adaptations ever documented in the animal kingdom. 4 kilometers down, we leave the open water entirely and touch the seafloor. This is the Abyssal Plain. One of the largest habitats on Earth, covering more than half of the planet's entire surface area. And yet it is also one of the least understood places that exists. There are no landmarks here. No coral reefs. No kelp forests. No visual reference points of any kind. Only a vast, flat desert of mud stretching for thousands of kilometers in every direction. Temperatures never rise above 4 degrees Celsius. Food arrives only as the slow trickle of marine snow filtering down from kilometers above. Survival here demands strategies unlike anything seen elsewhere on Earth. One of the most unexpected is size. Many animals of the abyss are giants compared to their shallow water relatives. Giant isopods, crustaceans normally the size of a thumbnail in shallow water, grow here to the size of puppies. Amphipods that would normally fit in a teaspoon grow longer than a human hand. Even the colossal squid, among the largest invertebrates alive anywhere on the planet, is thought to inhabit these depths. Scientists call this phenomenon deep sea gigantism. And despite decades of study, why it occurs remains genuinely unresolved. Some researchers suggest it conserves heat. Others argue it provides better defense against the few predators that exist here. Others propose it is simply what happens when an animal lives for centuries with no upper limit on its growth. Because time moves differently in the abyss. Creatures here grow slowly, reproduce rarely, and live for extraordinary lengths of time. The Greenland shark, which can dwell at these depths, has been documented living for more than 400 years. It is the longest confirmed lifespan of any vertebrate animal known to science. A Greenland shark alive today was born before the Industrial Revolution. Before most modern nations existed. When a whale dies on the surface and its body sinks to the abyssal plain, it becomes something rare and extraordinary in this food-scarce environment. An oasis. Within hours of the carcass touching the seafloor, scavengers gather. Sharks, hagfish, amphipods. They strip the soft tissue rapidly. But then, over the weeks and months that follow, stranger organisms move in. Bone-eating worms called osedacs colonize the skeleton itself, dissolving into the bones and feeding on oils locked inside. Entire ecosystems assemble around a single dead whale. Communities of organisms that exist nowhere else, thriving for decades on a single carcass, until all that remains is a fine scatter of mineral dust on the sediment. A whale fall is not an ending. It is a beginning. A temporary island of life in the middle of the largest desert on Earth. Beyond the abyssal plain lies the deepest frontier of all. The trenches. Carved by tectonic forces over millions of years, these are places where one plate of the Earth's crust slides beneath another, pulling the ocean floor downward into depths that challenge every assumption about where life can possibly exist. This is the Hadal Zone. Named after Hades. The underworld. It stretches from 6 kilometers down to the deepest known point on Earth. Nearly 11 kilometers below the surface in the Mariana Trench. To put that in terms that actually register, if you dropped Mount Everest into the Mariana Trench, its peak would still sit more than a mile underwater. Pressures in the Hadal Zone can exceed 1,000 times what we experience at the surface. To a human body without protection, exposure to these conditions would not be gradual. It would be instantaneous and total. And yet, life not only exists here. It thrives. The snailfish are the deepest living vertebrates ever discovered. Fragile-looking. Gelatinous. With thin, translucent skin that makes them appear far too delicate for an environment this hostile. But their biology is specifically engineered for pressure that would destroy any other vertebrate. Their bodies lack rigid bones. Their cell membranes are reinforced with unique molecules that keep proteins functioning correctly under conditions that would denature and destroy the proteins of any surface animal. They are not surviving despite the pressure. They are built for it. Recent studies of Hadal Zone amphipods found something that stopped researchers completely. Plastic fibers. Inside the bodies of animals living at the bottom of the deepest trench on Earth. In a place no human had physically reached until 2012. In a habitat so remote and so hostile that it represents one of the last places on the planet where human influence should be felt. The plastic was there anyway. It is a finding that forces a recalibration. The deep sea is not isolated from the surface world. It is not protected by its depth, or its darkness, or its inaccessibility. Everything we release into the ocean eventually reaches even the most extreme depths. The deep is connected to the surface in ways we are only beginning to understand, and the connection is not one-directional. Along trench walls, at hydrothermal vents where superheated water carrying dissolved chemicals spews from cracks in the Earth's crust, life takes a turn that reframes the entire concept of what an ecosystem requires to function. Here, there is no photosynthesis. No sunlight. No marine snow from above. The foundation of the food web is chemistry. Microbes that consume hydrogen sulfide, methane, and dissolved metals from the Earth's interior. Entire communities of tube worms, clams, and crabs that exist only because of these microscopic pioneers. This is a food web with no connection to the sun whatsoever. It runs entirely on heat and chemistry from inside the Earth itself. When researchers first discovered hydrothermal vent ecosystems in 1977, it fundamentally changed biology. Because it demonstrated that the sun is not a requirement for life. That complex ecosystems can assemble and sustain themselves on entirely different energy sources. And that changes the question of where else in the universe life might exist. Icy moons like Europa and Enceladus are known to have liquid oceans beneath their frozen surfaces, kept warm not by sunlight, but by internal geological heat. The same basic conditions that support hydrothermal vent communities in the Hadal Zone. To study the deep sea is not just to understand Earth. It is to understand what life is capable of. And where it might be found. Fewer people have physically visited the Mariana Trench than have stood on the surface of the Moon. Every expedition into the Hadal Zone returns with organisms that were unknown to science before that dive. Translucent sea cucumbers drifting through the water column like living parachutes. Gelatinous structures with no clear anatomy that dissolve before they can be properly studied. Microbes with metabolisms that do not correspond to any biochemical process previously documented. For centuries, the deep ocean was imagined as a lifeless void. Silent. Empty. A featureless grave at the bottom of the world where nothing could survive. What we have found instead is the opposite of that. We have found resilience at a scale that defies expectation. Life that has bent itself into forms that should not be possible. That has invented solutions to problems evolution has never encountered anywhere else. That has built entire worlds in places where, by every surface standard, nothing should exist at all. Nearly 3/4 of all deep sea life produces bioluminescence. 3/4. In an environment defined by total darkness, the majority of living things have independently evolved like light. Through different chemical systems. Using different molecules. Producing different colors. For different purposes. Hunting. Hiding. Communicating. Reproducing. Surviving. We still do not fully understand how many of these systems evolved. We still cannot explain why some species glow in wavelengths that no other animal can detect. We still do not know why deep sea gigantism occurs, or whether it is a single phenomenon, with a single cause, or multiple independent adaptations that happen to produce similar results. We do not know what the majority of deep sea species eat. How long most of them live. How they reproduce. How they navigate. How they communicate. For most of the animals living below 1 kilometer of water, we have a name and almost nothing else. The deep ocean is not a mystery we are close to solving. It is a mystery we have barely begun to ask the right questions about. And somewhere down there right now, in water so deep and so dark that no human technology has ever reached it, something is moving. Something we have never seen. Something that has existed, perhaps, for millions of years. That has evolved solutions to pressures and darkness, and cold and scarcity that we cannot yet imagine. That carries in its biology answers to questions about life itself that we have not yet thought to ask. The deep sea does not just hold creatures. It holds a mirror. And what it shows us, every time we send something down far enough to look, is that life is far stranger, far more resilient, and far more inventive than we have ever given it credit for being. We have explored less than 5% of it. The other 95% is still waiting.